Hi everyone, in this recording we'll discuss visual encodings. So from a very high level, you can think of all visualizations as being a link between the abstract and the concrete. Abstract because the data that we're measuring, we're only just seeing numbers with some sort of text labels. And concrete because when we look at a visualization, we're looking at physical marks, and each of these marks has some sort of property. Right, so here's like a visualization about data visualization. Think of what's going on the left. This is like a data frame. Each row is a sample. The columns are attributes about each sample. The right-hand side, this is your data visualization. The link that's being made is each row is being represented by one mark. So here, each row gets one circle. And the physical properties of these marks are determined by the attributes along the columns. So here, the x and y axis and the size of the points. All of this kind of physical information about each point is encoding abstract information from the data frame. Now, there are many, many kinds of ways to encode information. So we just saw location, XY location, and we saw size. You can change things like transparency, you could even change texture, color. There are many more besides this list even. So the question is, we have all these choices for how we can make encodings. What is a good choice of encodings for any visualization? Before trying to answer that, it's worth thinking about what are the actual types in your dataset. Do you have nominal, ordinal, or quantitative types? So in nominal data, you don't have any notion of order. So the name of a country, there's no natural order right away. If your data is ordinal, there's a natural ordering, but you can't say that between the first two and then the second and the third, there's a very big gap. So ordering, but not degree. And then quantitative, these are continuous data. You can make absolute comparisons, you could make relative comparisons. Okay, this is important because if you were going to try to encode, say, a continuous variable, it wouldn't make sense to use a color scheme like this. You wouldn't be able to just do blue, orange, and green. If you're going to do continuous data, it would make sense to have like a full color gradient, maybe different shades of the same color. Right, so that's the first principle. Any kind of encoding you do, you should make sure that the encodings are appropriate for the data type. Now, I presented it like it's a very straightforward thing, but in practice there's subtleties. So even something so simple as age, you could treat it as many different data types. You could be nominal, are you above or below some cutoff? You could be ordinal, you have different generations, or if you give the number of years, that's quantitative. Now, this idea of data types, it gives a kind of restriction on the kinds of encodings that you can give for a particular column. But just because you can give a certain kind of encoding for a column doesn't mean that you necessarily should. So there's a notion of a kind of hierarchy of encodings. So this is a screenshot from a study, and what they did, they showed the same information encoded using many different properties of these physical marks. Right? So it could be position, like the height of these bars. It could be angles. It could be area, circular or rectangular area. So it's the same numbers, but then representing them very different ways. Right? You're looking at the thing that's interesting is the relative size of these bars, these color bars. Right? It turns out that if you ask people to make some judgment about the size of these areas, people are much more accurate with some encodings compared to others. So they're actually, you can see these are the different kinds of encodings, and these are the errors that people make. So if you give a bar chart, common scale, you put the bars right next to each other, people can make very good judgments. But if you only show things as areas, you can still approximately make some judgment, but your exact values are going to be quite off. So this has a lot of implications if you are trying to compare many variables at once. It means that whatever you're going to be encoding using location on the screen, like the x and y coordinates, these are going to be read more accurately than things that are encoded using, say, transparency or color. So implicit in any visualization, you're prioritizing certain visual comparisons over others. Okay, to drive this point home even further. So one of the things our processing system is very good at doing, our eyes can tell a difference in color like this very easily. Like the red circle immediately pops out. But if I ask you, where's the circle versus the squares, look for it. You see it yet? Okay, maybe you see it. Okay. And then if I ask you the same and there are even more points, then it gets even harder. Okay. So if you're, and it gets tricky, here you're encoding using shape and color. It's going to be very easy for people to make the difference between the colors. Whatever variable, though, is getting encoding using shape, that's going to be read less accurately or less immediately. So the takeaway here is there are many kinds of ways that we can encode information. Whenever we're making a visualization, we are making a choice for our readers about what is more important to compare. Okay, so we'll see some more examples in later lectures.